Hello class, I hope you're having a good day today. Today we're going to discuss variables and graphs. Remember, in science it is key to communicate effectively, and so there are some really important rules that we need to follow and scientists follow when making graphs to display their data from experiments. We have the mnemonic tool dry mix, and it helps us remember that the independent variable that we manipulate and we're actually trying to test for is always going to be graphed on the x-axis. The dependent variable, the thing that changes in response to what we are changing to test, will always be graphed on the y-axis. Remember, the horizontal axis is our x-axis and the vertical axis is the y-axis. That means that our independent variable will always go down here, and our dependent variable will always go over here. So if we look at a time and distance graph like the one on the screen, then what would we get to decide? We would get to decide if we were driving someplace and the speed limit is 60 miles an hour and we're going to drive the speed limit, we would get to decide how long we're going to travel. And so the amount of time that I travel is going to determine how far I go. So in the example that we have on the screen, we've got our time we're measuring in seconds, and our distance we're measuring in meters. So if I decide that I am going to let something move for 3 seconds, then I can use the graph and I can figure out, because I get to determine the time, that will determine how far the object goes. Something really cool happens when we write our labels into our graph. Notice that our graph looks like a fraction bar, that diagonal fraction bar. If I write my distance in here, meters, and my time in here, seconds, all of a sudden I have a label, meters per second. Now let's take what we've just discussed and apply it to a different graph. In this graph, we have 2 variables. We have the time that changed and the temperature that changed. Look at the graph and identify the independent variable. What did the person who was doing the experiment intentionally change? If you answered time, you are correct, because time is on the x-axis. So the time that the person changed, they were trying to test to see how that affected the temperature. The temperature is the dependent variable because it's on the y-axis. We know that. Remember that we can write the labels of the variables into that graph line. And if we write degrees Celsius here and seconds here, then that gives us our label for our rate. So what we're measuring with this experiment is how many degrees Celsius a substance changes per second. So it's degrees Celsius per second. If you look at the graph on the screen, you'll notice that it's missing something. It does not have a title, and all good graphs in science have titles. Just as there are rules for where you place the variables on the axes when creating the graph, there are also rules for titling graphs. You should be able to look at a data graph and identify easily by the title what the independent variable is and what the dependent variable is. Graphs are always titled with the dependent variable first, and it's going to be versus your independent variable. So if we look at our graph, we see that our dependent variable, remember the dependent variable is on the y-axis. Our dependent variable is our temperature. And our independent variable, the thing that we changed, is the time on the x-axis. And so now we have a graph that when we look at it, we know right away that the temperature was dependent on the time in the title, and we see that they are located on the correct axes on the graph. Okay, now let's review everything by looking at an experimental question and identifying how we would graph it. So the question is, how does the amount of fertilizer affect the growth of pea plants? Well, the first thing that we need to do is we need to identify our variables in the question. How does the amount of fertilizer, so we know the amount of fertilizer is going to be changing, affect the growth of pea plants? Okay, those are our two variables. Remember, you can only have two variables in an experiment. So of those two, which one are you going to change? Which one is the person who is doing the experiment going to change? Well, we know we can't force the pea plant to grow a certain amount. So the amount of fertilizer, that is what we are going to change. And depending on the amount of fertilizer used, that is going to determine the dependent variable, the amount that the pea plant grows. So now where do we put those on the graph? Remember our mnemonic tool, dry mix. Remember that our dependent variable is here, and the y stands for the x or the y-axis. And our independent variable is here, and that goes on the x-axis. So now we can take that nice mnemonic tool and use it to help us. The amount of fertilizer is our independent variable, so it goes on the x-axis. Remember that we always put our label in. Whenever we label our axes, you always want to include the label in parentheses. And then the dependent variable, the growth of the pea plant, is going to go on the y-axis. So we're going to put growth of plant here. And that's going to be measured in centimeters. All right, now we've got our axis labeled. We could draw our graph. As fertilizer, as we increase the amount of fertilizer, the growth of the plant is going to increase to a certain point. Now we need to title our graph. Remember that we always put the dependent variable first. So the growth of plant versus fertilizer used. And if we take those labels and we put them in here, our centimeters and our millimeters, we get our rate. And interestingly, centimeters per milliliter growth of plant per amount of fertilizer used. That's it for today. If you have any questions, please make sure that you message me on Google Classroom or you join one of my Zoom help sessions. Have a blessed day.